In the present chapter of this course, we'll cover custom functions in detail. What is their main purpose? Why are they necessary as the complexity of our programs increases? How can we manage errors across functions? And more. In this lesson, we'll focus on the basics, how you can define your own functions and invoke them later from your main program. Let's get started. The concept of a function is no stranger to you. We have been invoking Python functions before. For example, the print function, or functions in the math module such as sqrt to perform a square root, or abs to obtain the absolute value for a number. But we can go beyond simply invoking existing Python functions, the so-called built-in functions, and instead define our own functions. Defining a custom function consists in grouping a sequence of statements and specifying the function name under which these statements will run. Then, whenever we call that function, our predefined sequence of statements will execute without us having to write them over and over. This is the syntax used to define a function. We use keyword def followed by the function name, open and close parentheses, and a colon. Then, at the next level of indentation, we include the sequence of custom statements that we'd like to execute when the function is called. Later in the program, we can invoke our custom function using the syntax you're already familiar with. We use the function name followed by open and closed parentheses. Let's look at an example. In this Python program, we'll define two functions. The first function is called print A, and its purpose is printing the first two lines of the song Twinkle, Twinkle, Little Star. The second function is called print B, and its content is in charge of printing lines 3 and 4 of the song. The so-called main program, formed of the sequence of statements to be executed when you run your code, is in charge of calling these functions to print the full lyrics with its ABA structure as follows: print A, print B, and then print A again. This is what happens when you run this program. The Python interpreter first parses all your function definitions. It remembers their names for future use, but it doesn't execute any of their statements yet. When Python encounters the first statement at the leftmost level of indentation, it considers it as part of the main program and begins executing it. In this case, Python detects that it's a function call, so it transfers control to the body of the function, which prints Twinkle, Twinkle, Little Star and How I Wonder What You Are. You didn't expect me to sing that, right? Control is then returned to the next statement in the main program, which is another function call, in this case to print B. Function print B prints the next two lines of the song lyrics, up above the world so high, like a diamond in the sky. And then it returns once again to the main program. The last statement in the main program is another call to function print A. This function prints the last two lines of the song, which are the same as the first two lines. Twinkle, twinkle, little star, how I wonder what you are. When control is transferred back to the main program, Python detects that there are no more lines to execute, and your program ends. Python calls are not restricted to your main program. Python allows you to define a function which, in turn, invokes another function, leading to what we call nested function calls. Here's another example of a small Python program where we can observe this behavior. The following program is meant to print a small shopping list by first printing the title on the terminal, followed by the list of items to shop. A function called printTitle is in charge of printing the title followed by a horizontal line made up of a sequence of dash characters. A second function called printShoppingList starts by invoking function printTitle and continues by printing a list of just two shopping items, bananas and strawberries. Finally, the main program prints text start, invokes function printShoppingList, and prints text end. Let's look at a step-by-step execution of this program. As we saw before, Python starts parsing your code from the beginning of the file. It identifies the first two blocks of code as two function definitions, and it remembers their names without executing them. Once it reaches the main program, it begins executing statements. The first statement prints start. The next line of code is an invocation to function print shopping list, which transfers control to that function. The first line in the function is itself an invocation to function print title, so the next step is jumping to that function. The code in print title prints shopping list and a horizontal line. When the function ends, control is transferred back to the line following the call to print title within function print shopping list. This code prints bananas and then strawberries. This function ends here, so control is transferred back to the main program at the line of code following the invocation to print shopping list. The main program prints end and exits. As you saw in these two examples, custom functions provide a convenient way for us to group sequences of related statements under a block of code that we can invoke one or more times from a main program or from other functions. The use of functions becomes essential as our Python programs grow in complexity, as they help us maintain an intuitive and well-organized structure for our code. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you and happy coding!